looking at some further curve sketching. Question 5G. So, okay, let's, first step, what are we going to look for? X-intercept? Sorry, y-intercept, sorry. Y-intercept, put x equals 0. And we've got y equals 0 plus 2 over 0 minus 4. Isn't that negative a half? So that's your y-intercept. I'm just going to do it now as well. X-intercept, put y equals 0. 0 equals x plus 2 over x squared minus 4. Now, yeah, that, well, yes, it has no solution. You know why? Because x would have to be negative 2, wouldn't it? Because you can't have the denominator 0. So x would have to be negative 2. Negative 2 plus 2 is 0. But if x is negative 2, the problem is that the denominator is going to be 0. So that's got no solution. Because the only way you can end up with 0 would be for x plus 2 to be 0, which means that x is negative 2. But when you look at x is negative 2 and plug it into the denominator, substitute it in, so then you get, for the denominator, negative 2 squared minus 4. Well, that's 4 minus 4 is 0. That's got no solution. You're not allowed to have a denominator of 0. So there is no x-intercept. Okay? Now, next thing, do you, just by looking at it, do you think it's going to be even or odd? The x squared makes me think even, but the x makes me think not. Combination of x squareds and x's, it won't be even or odd, or it shouldn't be. Let's just check. Function of x is x plus 2 over x squared minus 4. Function of negative x, I'm just going to write down what it is. Wouldn't that be negative x plus 2? What's negative x squared? Isn't it just x squared minus 4? And the negative function of x means just to put a negative in front of it. Let's put it on the numerator. Isn't it negative bracket x plus 2, which is negative x minus 2 over x squared minus 4. You just choose to put a negative either on the numerator or the denominator. I've put it on the numerator. Look, I can write it like this, negative of that, which is negative x minus 2 over x squared minus 4. Now, none of those three are the same. So, function of x does not equal function of negative x, and the function of negative x does not equal negative function of x. So, it's not odd, it's not even or odd. Neither even nor odd. In other words, forget the symmetry. You're not going to be able to do it that way. All right? But you can tell once you've got even and uneven powers, it's not going to be either. All right? Now, let's look at part 3. We always look for vertical asymptotes first. Now, we do that by looking at the denominator. So x squared minus 4 equals 0. It doesn't matter if you put equals or doesn't equal. We know we're looking for. So what have we got? You can choose to factorize it now or just do x squared equals 4, x is plus or minus. All right? So we can go x squared equals 4, x equals plus or minus 2. So now we're going to have to start doing a bit of a sketch. So we've got vertical asymptotes at positive 2 and negative 2. Now we know what to do now. What do? And I've got y-intercept at negative a half. That's what I've got. All right, let's start looking and doing some substituting. We're going to substitute. Look, it's not even or odd. Don't think, yeah, great, I'll just do one side and draw in the other. You can't do that. There's no symmetry. So let's start here at negative 2.1. Substitute x is negative 2.1. What do you get for y? Negative 2.1 plus 2 over negative 2.1 squared minus 4. Now, girls, you don't actually have to work this one out. I'll tell you why. Negative 2.1 plus 2, isn't that negative 0.1? And do you think the denominator is going to be, so that's negative. Do you think the denominator is going to be positive or negative? 2.1 squared is bigger than 2 squared. Whatever the denominator is, it's positive, you're going to get a negative. In other words, you can work it out if you want. Has anyone worked it out for negative 2.1? So isn't 2.1 squared, that's 20, negative 0. And you might think, oh, that's not very big, is it? So you're thinking it's sort of just here. Why don't you try Yeah, that's there. Negative 1.9, what do you do? All right, what do you get when x is negative 1.9? Y is negative 1.9 plus 2 over negative 1.9 squared minus 4. What did we get for that? They're not the big values that we're expecting. You know how normally we'll get 14, negative 10? We're not getting that. And the two values are very similar to each other. So what I'm going to do, we're just going to go back up to the top of the page for a sec, right? Just watch. Have a look. You know when we first looked at limits, when I look at this, x squared minus 4, right? And if I factorize that, isn't that x plus 2, x minus 2, right? And don't the x plus 2's cancel? And you know what this is telling me? That this graph is just a hyperbola. Ooh. But we do have a bit of a problem. You can't draw it all, but it's going to be a hyperbola. Part of it's going to be a hyperbola, part of it, with a gap in it. But this is telling me the gap's at 2. We may have another gap at 2. Can x equals 2? No, it can't either. So, we've got this problem where the two values on either side are very similar. You more than likely have a smooth curve but with a discontinuity in it and a hole. If this was negative 10, the other one's negative 10, that's fine. They're both, well, actually you still could have had a hole there as well. But let's just look at, if we think back to the last exercise, let's look at the following. The limit as x approaches negative 2, because these two values are very similar, of your function of x plus 2 over x squared minus 4. So that is the limit as x approaches negative 2. You know how we factorize that one? X plus 2, x minus 2, crossing it out. So it's going to be the limit as x approaches negative 2 of this function of 1 over x minus 2. What do you get? Negative what? Negative a quarter. This makes sense, doesn't it? Because even though you told me this answer was negative 0.25, it's probably negative 0.25 something. Anyone know exactly what that was? And this is negative 2564, you see. So what we've got is a hole and at negative 2. And this is lower down. The negative 1.9 side is lower down than the 2.1 side. All right, so it goes like this. And while we're here, why don't you test? Do you see? Negative 2 point, so this is at negative 2, right? Negative 2.1 on this side is negative 0.24, and negative 2.1 on this side is like negative 0.26. And in the middle, the limit that it approaches is negative 0.25. All right, so what we're going to do now, let's just do limit as x approaches infinity, or let's just substitute when x is negative 10. So I'm just going to go substitute x is negative 10 while we're here. I know we're sort of working on asymptotes, but this is the horizontal asymptote. I'm not finished, all right? Horizontal asymptote. Substitute x is negative 10 into the equation and you get y equals negative 10 plus 2 over 96. Negative 8 over 96, what do you get?
0.083.
It's approaching 0. Or I could do, if I want, so I know that's approaching 0. Now I still have, oh, see this negative a half? I'm going to put it down here. Because that's negative a quarter. Sorry, negative a half is about there. Got it? It's like that. You know how the y-intercept was negative a half? So I've got this curve like this. My next point that I want to test is 1.9, and I'm hoping it's going to go down like that. All right, so what I've done x is negative 10. You know, normally for horizontal asymptotes, we do limit as x approaches infinity. We can do that. But I can just see from this, it's going to approach 0 from below. Can you see it? I can do it, but really that's the limit as x approaches negative infinity. But let's just see. It is the limit as x approaches negative infinity. You get of x plus 2 over x squared minus 4. What do we divide by? The highest power. X on x squared is 1 on x plus 2 on x squared over 1 minus 4 on x squared And when I substitute, don't I get 0 over 1? Which is 0. We know it approaches 0. Whether it be positive or negative infinity, it's approaching 0. Now, that's good. That agrees with what I did. So this is what I've got so far. Okay? Now, does it make sense? You know why I went through there? Because the y-interceptor was -0.5. Now, I'm hoping it goes down here. So I'm just going to test 1.9, 2.1, and 10. X is positive 10. All right? And that should finish off the picture for us. So let's go. So this is a pretty horrible one, actually, girls. So let's do x is 1.9. So when x is 1.9, so we're still looking at the behavior of the graph around the asymptote, the vertical one. So you get y is, what do we get? 1.9 plus 2 over 1.9 squared minus 4. Anyone?
-10.
That's better. That's what we like seeing. And when x is positive 2.1, y is 2.1 plus 2 over 2.1 squared minus 4. What do we get?
10.
Great. And let's do, we know that as x approaches infinity, your graph approaches 0. Let's just do when x is 10, just to see if it's coming from above or below. Y is 10 plus 2 over 96. 0.125. Okay, let's put that together. Got it? So what do? Either side of the vertical asymptotes, we found the y-intercept, and when x is -10, x is positive 10. So let's keep going. When x is 1.9, I'm going to bring my graph down here. Actually, I'll redraw it. I'll draw it here. So I've got, when it was -2, I've got here -0.5. I've got here +2. Right, -1/4 is about there. This is what we've got so far, like that. When x is 1.9, we got -10, so down here. When x is 2.1, we got +10 up here. And when x was 10, we got just above 0, which means it's going like that. And we're done. Bit of a different one, that one. Okay. You know how we rearranged this and we played around with it and we said this is 1 over x minus 2? But if you look at the original, there are discontinuities at -2 and +2, like it can't be 2 or -2. Look, I've got the asymptote at 2, but I've got the hole in the curve at -2, but I do have the shape of 1 over x minus 2. That is the shape. If I said to you, sketch y equals 1 over x minus 2, you'd draw that and that without this hole. But because the function, it simplifies to that, that is the general shape, right? But because of this x plus 2 over x squared minus 4, we do have two discontinuities, one at 2 and one at -2. Just happens that the one at -2 is just a hole because this function factorizes to that. That's why that happens, all right? Another example, but this one's a bit different. This is really extension 2, not extension 1. And this one will have what's called an oblique asymptote. Now, and we're asked to sketch the function y equals, was it x squared over x, I think minus 2. Now, do you remember when we were doing limits and we started doing limits and I said, aren't you supposed to do, you know, if I want to do the horizontal asymptote for this first, do I divide by x squared or x? Isn't it by the highest power in the denominator? Now, if your highest power happens to be on the numerator, your function is not going to be easy to draw. The asymptotes are not vertical. They're oblique, which means they go like that. The asymptotes go sideways. Okay? That's what oblique is. You know, an oblique prism is a prism that's tilted. So, when your highest power is on the numerator, not the denominator, because let's just do the horizontal asymptotes, or any asymptotes. Do you remember how we're going to do this first? Don't I divide by, isn't it the limit as x approaches infinity of x squared over x minus 2? Let's say you forgot everything. You divide by the highest power. Let's say you go, no, yep, I'm not dividing by x, I'm going to divide by x squared. Let's see what we get. X squared on x squared is, so if I divide by x squared and you forget what you're doing, you get 1 over what? 1 over x minus 2 over x squared if I divide by x squared. But we're not meant to do it this way. What do I get? 1 over 0 minus 0, undefined. And you say, goodness me, that's right. That's the one where I divide by the highest power of the numerator. So I try again. The limit as x approaches infinity, so this is no good, of x squared over x minus 2, and I say I divide by the highest power of the denominator. Now, whenever you have to do this, your graph is not going to have vertical asymptotes. It's going to have oblique asymptotes. So that is the limit as x approaches infinity. Now, what's x squared on x? I'll actually write it all out. Over x minus 2 over x. So what's x squared on x? It's 1. It's x over, this is 1 minus 2 over x. Now let's substitute as x approaches infinity. You can't put infinity into x. You just keep that as x over 1 minus, what happens to the 2 on x? And what's x over 1? Now, your oblique, your asymptote is the line y equals x. Okay? Now, you know horizontal asymptotes, you know how you just get 0? It really is the line y equals 0. Horizontal. You tell me what the equation of this line is. Isn't it y equals 0? So when you're doing these asymptotes, they're y equals. Now, I'm not getting y equals 0. I'm not getting y equals 1. I'm getting y equals x. That is the line y equals x. Looks like this. When x is 1, y is 1. When x is 2, y is 2, etc. All right. So we've got that. So forget horizontal asymptotes. There aren't any. We've got an oblique asymptote. It's normal. So now we know no horizontal asymptotes. The curve's not going to be coming down like this. It's going to be going up like that or going down like that on an angle. All right, let's just do all our other steps as normal. And keep that there. What do we do next? So we've got an oblique asymptote. All right, what do we do next? Y-intercept. So you get y equals 0 squared over 0 minus 2. That 0 over negative 2 is 0. I don't need x-intercept. The curve passes through the origin. When x is 0, y is 0. That's good. Have a look at it. Do you really think it's even or odd? It's not going to. Don't think so, but we'll have a quick check. The function of x is x squared over x minus 2. The function of negative x is negative x squared is x squared over, replacing the x, all right, I'll show all working, over negative x minus 2, which is x squared over negative x minus 2. Actually, it might be odd. No, I'll just try it. Negative function of negative x. No, negative function of x, yep, is negative x squared over x minus 2. No. I can put that negative on the denominator if I want. You know how I say negative in front of that, right? I could have put the negative on the top, or I could have said that's x squared over negative bracket x minus 2. Are you okay with that? I can either put the negative on the top, numerator, or I can put the negative on the denominator. Negative function of x. If I put the negative on the numerator, it's that. Now, that is not the same as this, right? And if I put the negative on the denominator, I get x squared over negative x plus 2. It's not the same. Negative x minus negative 2 is plus 2. So it's not odd or even. Not odd or even. Or neither even nor odd. Why? Because the function of x does not equal the function of negative x. And the function of negative x does not equal negative function of x. We get x minus 2 can't equal 0, x can't equal 2. Let's look at the behaviour of the curve around x is 2. Just before 2, 1.9, we get 1.9 squared over negative 0.1. Anyone?
Negative 36.
Well, it's big. Negative 36. In other words, yes, definitely it's down like that. When x is 2.1, we get y is 2.1 squared over 2.1 minus 2. Girls, this is big. Because it's 2.1 squared divided by 0.1. Sorry? 44. Don't worry about it's up here. You right? Now, I still do have some unfinished business. Whoa, I don't like that. I shouldn't draw that all the way down. One sec. Now, -10, right, off you go. Do that. I'm not going to draw this down yet, but we're going to do when x is 10. Let's do +10, and then we're going to do when x is -10. So when x is +10, I get y equals 10 squared over 8. 100 over 8, what's that? 12 point? I want to do another one here. When x is 100, do that one for me. Y equals 100 squared over 92. No, 98. I don't like that value 12.5. It's not really helping me yet, all right? So I want you to do 100 when x is 100. 102 point? All right. 102 will do. So girls, when x is 10, y is 12.5. When x is 100, y is 102. It seems like the y value is a little bit bigger than the x value every time. Now, everyone okay? Coming up here, I told you about the horizontal asymptote, y equals x. So I'm going to draw it in, and I'm going to fix this up. Is the line y equals x? Now, I'm going to draw this a bit higher up. We know, for example, when x is 10, maybe somewhere down here, you know on the line when x is 10, y is 10, when x is 100, y is 100 on the line? Well, when x is 10, it's 12.5. Can you see it's above the line? And when it's 100, it's 102. It goes like this. It approaches that line. You can do when x is 1,000, you'll get 1,000 point something. The y value is always a bit bigger than the x value. See? If this is the 0.33, well, yours is going to be 3,4 or something on your curve. Let's look. When x is 3, I get 9 over 1. I get 3,9. I get 3,9. So it's sort of, it may not come down as far. It might just go like this. But it doesn't matter. You don't have to worry about how far it comes down. You're just doing a general shape. It is like that, all right? You okay with that? Can I set the negatives? All right, so we know it goes here. This is an asymptote, but it might come and go down like that, all right? So we okay? This top looks all right, not too bad. Later in the course, you're actually going to learn, when you learn to differentiate, where it actually turns, and you'll know, all right? But that's later. Let's do when x is -10. We might even do something like -1 and -2 to get an idea of where this is. Let's look at -1. What do you get? 1 over -3, -1/3. When x is 1, -1, I'm getting -1/3, which is, see, this is -1, -1. Do you get it? So it's up here. Do you see that? What about when x is -2? I get 4 over -4, which is -1. When x is -2, it's higher, it's here, about there. -2, -1. All right, let's do now when x is -10. I get y is 100 over -12. -8.3 roughly. So I've got -10. See, what's on the line? -10, -10 is on the line. Do you get it? If that's the line y equals x, when x is -10, y is -10. But I've got -10, -8. I don't go as far down as the line. Do you get it? It's above the line. It'll approach it, but it'll never touch it. You can try. Go and try -100. You'll go -98 or -99. So when x is -100, y is, what's -100 squared? It's 10,000 over -102. Anyone? Negative 98. So negative 100, negative 98 don't go down as far. And that's your curve. Isn't it lovely? So there you go. That's the graph. Now don't worry too much about this shape here and what it does. All right?
Okay, so that's not connected.
This cuts the asymptote. An asymptote is only an asymptote for large values. You are allowed to cross it and come back and approach it. Okay? This is an asymptote as x gets big, not when x is 0. Is x allowed to be 0? Yes. 0 over negative 2 is 0. I am allowed to have this point. So asymptote is an asymptote. The curve approaches that pink line for large values of x and for small values of x. Do you see? But that is extension 2. Should not be in your paper.